What questions you got for me?
Hold on. I had a sort of a couple of questions.
Okay. And I have the review up, so I can just show you the screen or whatever. So.
Okay. I just wanted to verify a couple of things.
Okay.
I have written down, but I put the stuff up, so just 1 second.
Oh, no problem. No problem.
Okay. First question is, when you fail to reject something, what is that saying? Because I'm just confused on what exactly that tells me.
Okay. Let me. I think unless needed, I'm gonna just share my screen, and then we can have a little bit better conversation about. Oh, that's just weird. All right. So what does it mean to fail to reject? All right. Fail to reject. No. Let me see what fun things the internet.
Am I supposed to be seeing something? Okay.
Is it? Hopefully.
Yeah, I'm seeing it now.
Okay. So I'm playing around here to see if I can find something that's got a nice little image on it. Okay. All right. So hypothesis testing, in a very grand sense, is why do we bother to do anything? You know, why do we go out and collect data? What's the big deal? And a lot of times we collect data because I think something's different. Okay.
Okay.
So when we decide we're going to collect data, that's what I'm testing, is that I think things have changed. So if I can't get any evidence, then we're stuck with the original assumption. Doesn't mean it's true, just means I wasn't successful gathering evidence. So the phrase reject and fail to reject is all in terms of that null statement. See if I can kind of pull this up. Oh, I had it up a second ago. Oh, man. All right, hold on.
So does it mean, like, when you reject the null, does it mean that you're rejecting the null hypothesis?
Right.
That means that the null hypothesis is not true?
Well, again, in statistics, we can't say not true. Like, I can't say I accept. I can't say prove. I can say there's evidence for or evidence against something.
Okay, so when you reject the null, then that means that the null hypothesis can't be proven.
Well, okay, so like in this lobster question, like number 11 here that I got up on the screen.
Uh-huh.
Can you see that, or you need me to make it bigger?
You can make it bigger, please.
Okay. Yeah, one problem is with using this little technology is sometimes it's hard to see, but I can cheat and I can make it bigger. And you're thinking that didn't make it bigger at all. Okay, that should have made it bigger.
Okay.
Okay, so the lobster question is, I think lobsters are different. I think, global warming, something is making the lobsters smaller. So I go out and I collect a bunch of lobsters, and I know from the past I expect them to be 3.2 pounds, and I'm trying to see, is there evidence that they're not 3.2 pounds? Okay, so when I go out in the real world and I collect the data, I expect there to be a couple above and a couple below and a couple right around 3.2, right?
Okay.
And when I come back, I find that when I add up all my lobsters and divide by the total number, that their average weight is 2.9, which is actually smaller than 3.2. So the question of what's the likelihood that if it's just random, if there's nothing going on, it's just random, that I got a sample that would come out to be 2.9, Well, that's where that p-value comes in. That's at 0.005. So in other words, if it's just random dumb luck that I grabbed 35 really small lobsters, really small meaning not much smaller than 3.2, the likelihood of it just being random chance is less than 1%. So is the fact that the sample that I'm holding, is that enough evidence to say that, yeah, I think the weight's changed? And that's where that alpha comes in. So the alpha level says, if my sample is so rare that it shows up less than 5% of the time, then I think that's good evidence that we can go ahead and reject the null hypothesis. So I'm saying I have enough evidence against the null that I begin to think that the null is not true. That doesn't prove it's not true. I just have really good evidence against it.
To doubt that it's true.
Correct.
And so when you write the null hypothesis, you're writing it in terms of it being true.
I'm writing in terms of
it's supposed to be true, but then you're proving that it is or is not, doesn't have enough evidence to prove that it is or isn't true, something like that.
Right. I mean, it's kind of like in statistics, prove is like the P word. We don't say prove anything. We just suspect or don't suspect.
Okay.
Yeah. The nice thing about stats is you never have to say I'm wrong. You just say there's not enough evidence to show that I'm right. But at the end of the day, it's just what does the evidence suggest? And in this case, the evidence suggests that we can reject the null. There's enough evidence to say that the null is wrong. But then,
okay. So do we ever reject the alternative?
Nope. We always do it in terms of the null.
Okay. And the null is always mean, the mu or p or whatever it is symbol that you're using is always equal to what's stated in the question, right? The mean,
the variable
is 3.2.
Right. So the variable that we use, the symbol that we use, and the number that we use depends on what type of problem we're dealing with. Like, let's see if I can pull up a different one. Like number 12. Number 12 is what's called a matched pairs test. And so in the matched pairs test, you have that mu of D, which is the symbol for matched pairs. Number 13 was a one sample proportion test. And so the symbol for that is just P. So the variable you use depends on the type of data you have. And the symbol, whether it's, I mean, the null is always going to be equals. But it's an alternative. The alternative could either be less than, greater than, or not equal to.
Okay.
And you kind of have to get that from reading the situation and deciding, okay, so what do they, like in number 13 here, it's got this phrase, is owning pets is less than 53%. Well, that means I suspect it's less than. So that's what my alternative is, less than. But in number 14, I've got two different sales statistics, and I suspect that one is lower than the other. Anyways,
okay. So once the p-value is greater than the 5%, then you fail to reject automatically.
Yes.
Okay.
Yes. As a matter of fact, like right here, anytime you see greater than alpha, without even thinking, you can just write fail to reject, and that's not enough evidence for. Now, technically, we should be writing sentences, and we should be writing this out in words and saying, you know, it's not enough evidence for whatever the null hypothesis was or whatever the alternative was. But for Wednesday's test, this is perfectly fine.
Okay.
Just bare bones answer.
But for the final?
Same thing.
Okay.
I'm not, I mean, this is an introductory statistics course, so I appreciate that if you can get, a lot of times if you get the p-value, that's, to me, that says that you understand it. Don't stress about writing the English language behind it.
Okay.
Yeah, so on that conclusion based on p-value, I'm just, if you got the right connecting statements together, then I'm happy, and that I'll give you full credit for it.
Okay. And I know on the examples that we did yesterday, well today, well what's today? Tuesday?
Yeah.
Yesterday in class on our review sheet, most of them were basically just one proxy, two samples, and that kind of stuff.
Right.
We got the p-value from that screen. Are we going to have to get the p-value from Norm CDF on at
Nope.
all,
Nope. You can get
or
that
are we
straight
just
from
getting it
the.
from that one screen?
You can do them all from the test screen.
Okay. And for the for the type 1 error and type 2 error,
Okay.
um, let's see. We said that, or this is how I understood it, was that where is it? Was what type 1 error means that you think the alternative is true when the null is true.
That's correct.
Okay. And then the same thing for type 2, you think the null is true when the alternative is true.
Right.
Okay.
And again, error sort of has this idea that someone made a mistake, and that's not really what error in statistics is. It's what that alpha that we say is defines whether it's statistically significant or not. Sometimes it is rare. Sometimes it is just random, and we should go play blackjack because we're just going to win really small odds. So when we look at the error, we go, well, which decision is worse? Which one are we more concerned about? Okay, that one I don't want to have happen, so I'll make sure my alpha is the appropriate level. In our class, we've I think every example we've done, alpha's been 0.05. But depending upon type 1 and type 2 error, there would be a reason why you might want to go to 0.1 or 0.01. If you're trying to avoid type 1 error, then you want to have a really small alpha. The problem is if you have a really small alpha for type 1, that means you have a bigger opportunity to do a type 2. But again, we talked about the theory, but we didn't really do any, I didn't put any practice in about you have to decide which alpha is the best one and then make a decision off of that. But that's out there also. But don't worry about that. I'm not going to put that on the test. You can do just fine with 0.05.
On number 13.
Okay.
That was the next one. On number 13, for A, when you find out if the sample distribution is normal.
Okay.
Because it's proportions, it has to be greater than 10, correct?
Right.
And if it's means, then it has to be greater than 30.
Yes.
Okay.
Yeah. So you have to. That was like in the videos in the lecture notes. There were a couple of conditions in order to say that these p-values have these significances. And the only condition that I'm going to put on this particular test is whether or not it's normal. So I'm just emphasizing, are we aware whether it's proportions or means? There are different rules if it's a 2-sample proportion versus a 2-sample means. So just
okay, that's the other thing. If it's a 2-sample mean, Then how do you get the normal from that?
You have to either do a box plot. So if you have the raw data, then you do a box
Okay.
plot for each set of numbers. Or somewhere in the problem it says that the population is normal. Or you've got sample sizes for both samples that are bigger than 30.
Okay, and then you'll just basically you don't have to calculate. You'll just have to read it in the problem. Basically, it'll tell you your sample size because they have to, or they'll give you the data.
Right. Right.
Okay.
It's for our test, it will be normal. It has to be because we don't know how to handle it if it's not. So everything
Okay.
that we're going to look at will have normal to it. Your job is to tell me which condition is satisfied to make it normal.
Okay. It's the reason why I was asking that one is like on our previous test, it was a question that says, "What type of sample distribution is this, and how do you know?" That was the question, and I had wrote that it was normal because of the box plot, and I guess that was wrong.
Well, what I was looking for on that is I wanted you to say either proportion or means, and then
Okay.
tell me the appropriate fact with it.
Okay.
So a lot of students either didn't even say the word proportion or means on there. Honestly, when I at the end of the test, when I looked at how everyone did on that one question, I kind of regretted asking it the way I did.
Okay.
I mean, I kind of walked away and went, yeah, all right, that didn't go as I thought in my head. It would be a little bit easier, and most students had no idea what I was asking. So, but on a grander sense, I also adjusted a couple of questions.
Okay.
So no one really failed because of that question, but it is something that I want to address better next semester.
Oh, I wasn't saying, like that. I was just meaning I just didn't want to make the same mistake twice. Like,
No, no, no.
I try to understand what you meant when you said it.
When I looked at what everyone thought I was asking versus what I thought I was asking, it was a disconnect. So it was a bad question.
Okay. Okay. So on the sample means then, when you get the well, since you said it's normal from the box plot or whatever, I guess that doesn't apply to the like number 15, how you had to take the 10 and divide it by both sides.
Okay, so on number 15, you've got a two sample proportion,
Right.
and this is the one part of statistics that I'm embarrassed to say. So normally, when in a math class, all textbooks should be the same. And I taught it one way when I was teaching high school, and I found about 3 different textbooks. One of them agreed with me, one of them disagreed with me, and so this one particular condition changes depending upon who the author of the textbook is. So for me, I'm just going to say it's n time the sample size times the probability of success has to be greater than or equal to 5, and then the sample size times the probability of failure has to be greater than or equal to 5. So is that in the video? I think it's NP, NQ have to be bigger than or equal to 5. So as long
Okay.
as I see some sort of statement like that, then you're fine. But you're only going to see this once, so don't get too stressed if you're like, I have no idea how to write that. Well,
Okay. And then on yours, the probability of before and then the is B and the probability of A is after, correct?
that's now again,
Could you
technically I should be writing a sentence that says B means before, A means after.
Okay. Well, I figured that because it's obvious in a way. But my question was, can you write P equals PA equals PB?
Like for the null?
Right. Instead of P before equals P after, you can't do P after equals P before.
Oh, you can. I mean, you can switch the order around.
Okay.
You just got to be careful with that, because like on 15, it's our alternative is not equal to. So switching the order is not going to do anything for you. But
Okay.
on some of the other questions, depending upon which one comes first, you either want greater than or less than.
So basically, for number 15, I could switch it around, but if it were asking if it was greater than or less than, then I would have to put a different order for the B and the P, right?
Right. So like
Okay. I
number,
mean B and the A.
let me look for my two sample. Oh, here we go. Number 14 is the two sample mean one. So on that one, I'll make it bigger. Okay, so on that one, you can decide what you want to label it. Like again, B means before and A means after. But in order for here are the sales, that this guy's excited because the sales increases. So should he be excited? Is sort of the question. And
Okay.
if I put A first and make B after, then I would just switch the inequality to be greater than instead of less than.
Okay. So basically, I have to pay attention to the question asking, is it before or after going to be greater than, less than, or neither?
Right. Because and like in number 14 here, there's nothing for me to underline and go, that word means less than. Like some of the other ones definitely have the word less than or greater than in it, but in this particular question, it doesn't have it in there.
Okay.
It's just an implied, we're assuming that the amount of sales went up.
Okay.
So if we're assuming they go up, that means it's got to be greater than.
Okay. And then, okay. Okay. And then this was the T test. So this is a mean.
Yeah.
Okay. At first I thought it was a percent, but I guess.
Well, yeah, in this one, even though there's a 6% here,
That's just extra.
That's just extra. That's just there to mess with us. He's actually asking, we went from 49 to 52. Clearly it got bigger. Is there enough evidence saying that clearly they're selling more stuff? And because we got that p-value of 0.08, yeah, you sold more stuff, but you also have more stores. So your percent actually is not as great as you would suspect it to be.
Okay. And on the Z test and T test as appear in the beginning, basically, because I think, I don't know if I was reading too much into all of this, but basically everything here that I looked at or been going through is either a 1 sample or 2 sample T or Z test, or a 2 or 1 sample or proportion Z test. You know what I mean?
Right.
So am I correct to think that, or am I supposed to be looking for something else too?
Okay, so when you read this, the scenario, you got to first figure out, is it 1 or 2 sample?
Right.
Okay, and then what you do next depends on what you got. So if it's a 1 sample, then you want to ask yourself, is it proportion or means? If it's proportion, it's a Z. It's a 1 prop Z test, stop thinking. If it's means, then you got to go one more level and ask yourself, well, do I know the population standard deviation? There's always going to be a standard deviation there. They have to give you some. But the question is, does the number they give you represent just the sample or represent the entire population? If it represents the population, that's where a Z test comes in. And if it represents the sample, then that's where a T test comes in. And then we go on to 2 sample. So if we got a 2 sample go ahead.
I'm sorry. So first you decide 1 or 2 samples.
Right.
If it's 2 samples, then you either, well, actually, if it's either one, you decide if it's a proportion or a means,
Right.
right? If it's a proportion, whether it's one sample or two samples, it's automatically a Z.
Right. With proportion is.
Okay, so if it's a one sample or a two sample and it's a means, then you need to find out if you have a population standard deviation or if you have a sample standard deviation.
Right.
Okay, and if you have a population standard deviation, then it's a Z.
Yes.
And if it's a sample standard deviation, then it's a T.
Correct.
Ah, okay.
I thought I was pulling up a helpful document, but now that I'm looking at it, I'm like, let me try again. I think I've got another one. Testing decision. I think that's the one. Okay, so here's this nice, lovely chart that I will make bigger. Let me decide how much I want out of this. Yeah, I'll probably just take the whole thing.
If it's a one sample or two sample proportion, it will give you the standard deviation, or do we need to find it? Because I don't remember.
No, that's why you can go straight to the calculator. Because once you've decided which test it is, you just go to that calculator menu.
Okay. So you don't have to look it up. Just go to the menu and.
Right.
So
right.
what if it's a proportion, but they don't give you the standard deviation?
If it's proportional, they just have to give you a success and failure. So I'm sorry, not success and total number of the sample size. So they don't have to let me go back to something with a one prop Z test. Huh? Yeah, then my other one kicks in at 10.
Could you move your daughter?
Yes. Yes, I will move her. She was having a rough night without you.
Okay.
Okay, so like a number 13.
Okay.
They don't give a standard deviation in there anywhere.
Okay.
They tell you that there's 400 families, 192 of them own pets. City Council would like to know if it's less than 53%.
Right.
Didn't say standard deviation once. Now, last test, so for unit 3, I did ask you to give me the standard deviation because there's a formula for that. That's just the square root of n PQ over n. So we can find it, but since we're going to the calculator and we're just going to type in all the statistics that they give us, the calculator actually will tell us what that standard deviation is.
Okay.
So the same screen that I get the p-value from,
yes,
will also have the standard deviation on it.
Okay. And then okay. Okay. Because on this one, even for the alternative and the null, well, the null I was okay with, but the alternative, I was initially thinking that the sign was greater than the probability, the proportion being greater than 0.53. I don't really know why.
Why you thought it was greater than, or why it should be less than?
I mean, less than 53%. Okay, never mind.
Say that last question says, does the data indicate that it's less than 53%?
Yeah, I see what I was thinking. Never mind. Scratch that.
No, it's okay. I mean, this is kind of the tricky part.
All right. Well, I don't know if I have any more questions. Oh, on our notes that we take tomorrow, are we using the original one that you gave us with the distribution binomial usual? That paper in addition to this HTCI paper?
I wouldn't.
Okay.
I guess that's not what you asked. You asked, am I using the other paper too? No, that paper was for test 3. The chart that I gave you, I think yesterday, I think you were the last one to get that.
Yes.
Anyway, so that chart, now keep in mind, everyone else has been, every day they come in, they've been using that chart to answer questions.
Right.
And they're just now, some of them are just now going, oh, I understand why this chart is helpful. So I understand you getting it just the day before the test, probably a little culture shock right there. But
I think I can pretty much understand, like the reject and the fail.
yeah.
Yeah, if it's greater than the alpha, then you fail to reject.
Yeah.
And then if it's the other way around, then you reject the no.
Right.
And then, like you said, for the H alternative, it's equal to, less than, greater than. Well, it's not equal to, or less than, or greater than, I should say.
Yep. And like we as we went along in each unit or each lesson, we added a few extra little things here and there. So if you want to give yourself a couple extra notes just to have it make more sense and be useful, then go ahead and do that. But technically, if you understand what the chart is trying to say, technically you don't even need the chart. But again, it's there to help make things a little bit easier for you.
I'll use the chart. Every bit helps. Trust me.
Every little bit.
What was I gonna say? Oh, and somebody said a sheet of paper in addition to something. Is that for the final, or was this for?
That's for the final.
Okay, so for the final, is this paper, the HTCI, our binomial and all that notes, and an additional sheet of paper?
Right. So we got our normal formula chart that we have every test.
Right.
Then unit 3, I gave you that additional little help.
Right.
That did or did not help. This
Well,
test, I gave you that chart so that kind of help it keep it straight what you're supposed to think.
Okay.
And then on top of that, you can add extra examples from your previous exams.
Okay. Oh, are you going to bring the other tests tomorrow?
The keys?
Yes.
Well, technically, I've been passing them around the day after the test. I'll track them down.
Well, I know we had talked about it earlier, but if you can't find it, it's okay. I
have them. I'm just like, well, you already have it.
No, the first one, it went around, but I didn't really look at it. I really looked at the third one. I didn't look at the second one because
okay.
I think I was at work that day when you passed that one out.
Well, the Friday, the test review day that review session set aside for Friday, I think that was the main intent, was to let everyone get their test 4 back that are able to get it back, and then let them look at the answer keys, and we'll kind of look at a couple practice questions, and but for the most part, let's at least make sure you've got the right answers for your tests. Is kind of the big deal for Friday.
Is there any way you can put it up for us? Because Friday I have to work, and I'm not going to be able to make it in the day. Because I think they said from 10 a.m. to 11 a.m.
I am open to that. I will probably say if you shoot me an email and ask me to scan them, I will remember when I'm at my office. Otherwise, I will probably forget.
Okay, I'll do that. When do you want it? Like
Thursday? Let's do it now.
Friday? Oh, now? Okay.
Yeah, sure. I just need to be near the scanner at the time. So it's nice and all that we're talking, but I won't get a chance to actually do anything about it till tomorrow afternoon.
Okay.
and you know how that works. You know, it's like, oh, I'm supposed to do something for somebody. I completely.
Yeah, I trust me. I understand. I got a lot going on too. I understand. Okay, I'll email you to get that because I'm not going to be able to make it on Friday.
Okay, but
Yes.
that's fine. It's
Are
just there
you
to
doing
help.
anything? Well, I guess we can talk about that Wednesday. If you do anything online for the final, or just basically study our past tests.
Right, right. I think the problem I'm having is I don't know when I can get online.
Right, right.
You know, it's like Friday night, Saturday night, you know, Sunday night I'm doing family stuff, but I right now I'm not. Honestly, what I want to see is I want to see how test 4 goes. Because if test 4 is a disaster, I'm gonna feel bad, and then I'm like, okay, I need to sacrifice something, and you know, my kids just don't get to see me from it. But if test 4 looks great, then I'll be like, all right, they got this. They don't need me to pay attention to them.
Okay. Well, I hope so. We'll see.
Right, right. I'm hoping everything comes
It
out
doesn't
rainbows and
seem as
roses.
bad as the other ones, but
Oh, Gene, you're doing fine.
we'll see.
All right. Anything else you need help with?
That's it.
I never did check to see. I don't think anyone showed up. I think it's just you and me. It is. Okay.
Yeah,
That's
you
cool.
did say that.
No, it's fine. I mean, that's totally fine. I
Yes, that
will.
helps me. I'll take advantage of it as long as I can. I'll take advantage of
That's right.
it.
This might be our last real conversation because here on out, I'm just staring at you taking a test.
Right, right. And crying.
That's
Have some
no,
tissues.
Gene. You'll do fine. All right. Well, I'll post the link. Hopefully, yeah. It looks like I did remember to record it, so I'll post the link so that anyone that wants to watch us chat can entertain themselves. I don't
All
know.
right. Thank you.
All right. You're welcome. Have a good night.
You too. Good night.
Bye bye.
All right. What do you mean?
You know, I've been parking in the covered parking.
Yeah.